Now, when I look at that derivative, c prime, I have to consider, when does c prime not exist? Well, c prime does not exist when the 10,000 t squared minus 19,200t plus 14,400 is less than or equal to 0, because we can't take the square root of negatives, and we can't let that denominator equal 0. That's why it's less than or equal to 0. If you just set it equal to 0 and tried to solve for t using your quadratic formula, you would find that there are no real solutions. When you try to solve the inequality, you'll notice that there are no values for which that expression is less than 0 in our domain. And our domain in this case is between 0 and 1.5 hours, because we're told that one car leaves at 3 o'clock and the other car arrives at 4:30, so the whole event only occurs over 1.5 hours. So now we have to consider where c prime is equal to 0, and that will occur when our numerator is equal to 0, or 0 is equal to 20,000t minus 19,200. We rearrange and solve for t, and we find that t is approximately equal to 0.96 hours. When we convert that to minutes, we find that t is approximately equal to 58 minutes. Therefore, we can conclude that the cars are closest together at 3:58 p.m. Now, normally what we would do is use that time, 0.96 hours, and we would check that it is indeed a minimum by looking at c double prime, or the second derivative of our function. We're not going to do this because it's such a long and cumbersome process. If you are required to do that when you're at your post-secondary institution, that's fine. You'll have to do it at that point in time. But I'm really not concerned with it at this level. I think that if you can get the critical points and recognize that probably this critical point, the only critical point, is a minimum, then that suffices for now.